Can you hear me? Oh, okay, yeah. All right, so I hope you like stories. But actually, before we begin, how many of you ever worked on some ML project? Okay, quite a few. Okay, nice, nice. And how many of you experienced the failure of this ML project? Okay, so most of the people. All right. So yeah, we'll start with Fable. I hope you like stories, and after that we'll do some takeaways and some debrief. All right. Yeah, first about myself. I'm actually not at development aid for almost half a year. I'm an independent ML and MLOps consultant, and here is how you can find me. Yeah, all right, let's get started. So, not so long time ago, in a corporation not so far away, there was a machine learning initiative, of course. And as any machine learning initiatives, this one started with the idea that they need a proof of concept to assess whether they are ready to do ML and whether ML would suit their business needs. Now, our company is called Lupin Corporation, Lupin Corp for short. They're a logistics company, which is very old. It was dated back to a revolution, but no one remembers which revolution it is. Maybe it was French, maybe it was Soviet one. And they have some core tenets. One of these core tenets is the fact that they are very cost efficient. So history taught them to not waste money, basically. Also, they don't like taking unnecessary risks. Yeah. So if you know the adoption cycle curve, they're basically laggards, together with some governments and big banks. Although they hope that they are late majority, they're not. Yeah, so Lupin Corp is also reputable for doing their due diligence because, well, this minimizes the risks. And before they launched their machine learning initiative, they decided that they need to do their homework. They need to know what are the prerequisites for a successful machine learning project. Yeah. First of all, they defined their success matrices. So they knew how to know whether they're doing good or they're doing bad. Then they also made sure that they not only have data, but also that this data is easily accessible and discoverable by future data scientists. So they had basically a data catalog to know what data sets are in the company and what data isn't available. Finally, leadership knew that data science and machine learning is not your typical software engineering project, meaning that the risks are higher and the results are more unpredictable. And they were ready to dive into this. So, yeah, actually, yeah. They are much better than most of the companies that start machine learning initiatives. All right. An important disclaimer for those of you who still believe that Lupin Corp is a real corporation, it's not. And it's not just a masked name for some of my previous employers. It's more of an amalgam of all my previous employers plus some industry stories. So if you're some of my previous employers, it's not necessarily about you. Yeah, Lupin Corp started with a proof of concept, and they needed some machine learning data science people. So they decided to create a small team first, and they hired 2 data scientists. First was Nifel Nifensen, who you can see on your left. Yeah, I'll make sure that everyone can see it. Yeah, he had about 2 years of previous data science experience. Now, what? Okay, yeah. Now they also hired a more senior person. Her name was Nafaela Nafari. She was a PhD and had about 6 years of experience. Yeah, so Lupin Corp basically asked them, look, we need results and we need them as soon as possible. And they delivered. Actually, not only delivered, they over-delivered because the results were really good and senior management was very happy about that. Because the results were good and basically the proof of concept proved that, well, we can do better and we can scale, they decided to expand the team. But as all things related to scale, cracks started to show. Now, Nifel, Nafaela, and the new team were a very pleasant team to work with. You know, you almost felt like in a family. although with boundaries, of course. But somehow, team's velocity, or as I like to say, team's throughput, wasn't scaling as expected. Not only that, but actually after a few months of the existence of this team, the velocity actually started to go down. Now, why would that be the case? Well, first of all, many of the promising experiments that this team were doing couldn't be replicated. Imagine like Nifel, for example, developed some analysis or maybe a classification model, and he's very happy that the performance is very good. And then he tells to Nafaela, look, I did an amazing model. Now when he tries to rerun the same code, the results are different. It's actually like even worse than with code, because with code you can at least debug. Now you will not be able to debug this. Yeah. Also, they observed an increased number of complaints from the models, from the machine learning solutions that were deployed. In time, they first received praise for the effectiveness and the accuracy of said models, but in a few months or even weeks, the performance degraded from the point of view of predictions. So predictions became worse. Finally, again, because initially there was great success, they started to receive a lot of traffic on some of their API endpoints which were serving the machine learning models. As a result, they also had pretty bad scaling problems. Thankfully, they knew about Docker, and they were using Docker to pack these machine learning models. First thing that they did, they decided to horizontally scale, like basically like replicate the service 100 times and put a load balancer. Of course, it worked, but it wasn't resource efficient, first of all. Then it was also pretty hard to manage. Like imagine managing 100 Docker containers without like proper infrastructure. And finally, their latency SLAs were out of the window. So no one could discuss about this. They were always broken. Yeah? I actually counted. It's the 7th time during this conference this meme appeared. Yeah, and I thought I was original. All right. No, but it's very good, and it very well defines like what happens in such situations. All these problems were very annoying for everyone, for the management, for the team. So they decided to bring in the big guns. Now, Lupin Corp hired a new head of data, and his name is Nufelman. He's from Odessa. Yeah. He worked in a non-fang company. Basically, the company was structured like Lupin Corporation, but the culture was different. And as you can see, some of the tenets of this culture is that with great money comes great problem solving. So they were the type of company which throws money and hopes for the best. Yeah, so Nufelman was a firm believer in the power of money. He was also a firm believer in DevOps, which is actually kind of cool. Now, he analyzed the problems that were in that team, and he understood that they faced a replicability problem, and the retraining problem, and the scalability problem, and like a ton of problems, all right? He understood that the team lacked a process to reliably research, develop, evaluate, and productionize models. Sounds almost like code. If we don't talk about models but about code, like DevOps kind of solves this. So he suggested that they need to adopt MLOps, fully and without question. Now, please remember these two words, fully and without questions. Some of you might ask, okay, but what is MLOps? Maybe some of you will infer this, others don't. But yeah, basically you do DevOps, but you have additional complexity from machine learning models, meaning that you have to train these models, and then you have these big binaries which do magic. So it's the ML part. All right, so to streamline adoption, Nuf decided that it would be unwise to develop these tools for the MLOps lifecycle in-house. So he decided, well, why not pay for the thing? So like, you know, buy versus build. Now he decided to buy. And he decided to buy a machine learning platform as a service from an IPO called All You Need and a Kitchen Sink. You can see the ticker, yeah, which solves all the MLOps problems. It worked. Most of the problems went away, at least the major problems indeed disappeared. But a lot of processes, a lot of internal processes which were developed before NUF came into the company weren't as easy to do with the new tool. Also, people didn't really like using it. It had a steep learning curve, and it was a huge monstrosity. Now, also, because it's a paid-for solution which does everything, now it costs as much. The enterprise tier actually costed something like a seed investment grant per month for a startup. Depending on how you define it, it's like from high hundreds of thousands of US dollars to millions. Yeah. Well, as you know, burning cash does have some consequences. It did indeed have consequences for Lupin Corp. And again, people weren't satisfied. Now management who believed that they need to be cost efficient also wasn't really satisfied. Yeah, they needed to increase operational efficiency, but it was like, you know, on the back burner. It was something like, well, as far as it works, but eventually we'll need to switch. Eventually came earlier than they expected. So for those of you who don't know, earnings call is a special procedure between the shareholders of a public company and, well, the company, where the financial health of the company is declared and some future roadmap is defined so that you should satisfy like your shareholders, meaning people who own shares of the company. Financials showed that Lupin was wasting considerably more money than their competitors. And because this is like an old established business, it's not good. Shareholders didn't like it, stock market didn't like it, and they experienced a 20% drop in their stock prices in a week. I mean, it's something between Meta and Netflix. So, yeah. To alleviate the issue, Lupin Corp decided to cut the costs. And first of all, they laid off employees working on non-critical business projects. It was clear that the main reason this whole mess happened is because of this BIDE ML platform. ML initiative was, of course, impacted. Nafael and Nuf stayed, but Nifel was laid off. Well, they basically picked by seniority. Poor Nifel. Well, again, it worked, but Lupin Corp did understood that it's not a sustainable way to solve the problem. They needed something more fundamental to optimize their operational expenses. So they started now really to look for someone who could help. Meet Nahum Nahreba. Yeah, this is his tenant. He's a platform engineer. He's known for thinking like from first principles and designing like amazing systems. You could say that he's something of a Jeff Dean, but in that parallel universe. You know, maybe he can't shift bytes between computers, but well, yeah. He knew already how to work with ML platforms, so it wasn't something really new for him. Yeah, you can see Nahum Nahreba on the right, persuading Lupin Corporation on the left to allow a major refactoring of ML platform. And most of you, I think, know how painful it is to convince your management that you need to refactor this pile of code. Don't let the horse distract you. Management was persuaded. So they did refactor. And yeah, well, I'm not going to dive deep into how they refactor. Basically, they reduced their bill for that MLOps platform. They developed some in-house tools. All hail Nahum Nahreba. Yeah, and they lived relatively okay. Now, like everyone is here also for some advice, not only for fun stories, right? So how could Lupin Corp avoid this mess? I think everyone knows this, this quote, right? So premature optimization is the root of all evil. God forbid you do optimize your code before, no, in the very beginning. Only the code doesn't quite look like this. It's actually more like this. Yeah. So we should forget about small efficiency gains and then premature optimization, but we should not pass like the obvious opportunities for major gains, like the critical 3%. Not everyone knows this whole code, this context of the code. So takeaway number one is to start early with MLOps. But you don't need this. So for those of you who are far away from the display, basically it's like it's MLOps at 11, you know, like not 10. But so you have everything here. You have automation. You have CI, CD, CT meaning continuous training. You have feature stores, which you'll Google later. What does it mean? Because I think we don't have time for this, or maybe ask questions later. So a lot of stuff in here. You don't need this complexity. What you do need is to make sure that your models are trained in a replicable way, meaning that you have to seed the model training code. Seed refers to the random number generator, which is like ubiquitous in the whole machine learning training code. Now, you also have to record your experiments so that you can come back later and understand how, again, to replicate the results. You need a way to deploy your models easily. The Lupin Corp did that, and you need to have some tests. All right, yeah. So using a fully featured MLOps solution, as Lupin Corp eventually did, wasn't a good idea. Now, why wasn't it? Because first, it's too generic. So you always have to add some glue code, some custom hooks to it. Maybe a lot of you who use cloud solutions and specifically higher level tools which kind of do, for example, OCR for you, or who do code inspection, eventually you have to customize it, right? So it's the same issue here. Then you have a lot of upfront costs. This stuff costs money. And finally, it's hard to onboard because you have to learn a lot quickly to be productive. Doing full MLOps from the very beginning, it kind of has the same problems. Maybe less with upfront costs, but the rest, yeah. So takeaway number two is to start small with MLOps. So do it incrementally. Yeah, now for the advice. So first and foremost, you need data collection and discovery. And Lupin Corp did that, but a lot of companies don't. And why do you need that? So organizations do have data. Thankfully, in the last, I think, 10 years, a company started to think, oh, we need to collect data. But now another problem appeared. Okay, they have data, but where do you find it? So where is it put? Who to ask for, right? So for this, my suggestion, initially, so it's not a fully fledged solution which you'd want to use in an enterprise setting, but for a proof of concept, you basically need to do backup of your database, and I hope all of you do that already, and dump it into a bucket, S3 or Azure Blob or whatever. Then you need some automation. So for example, I don't know, RPA, or maybe just some Selenium scripts. Ask your automation QA engineer to write it, which will, on schedule, again, for example, export what? Yeah, so coming back. Yeah, so you're gonna need also some automation because, for example, some data is stored in some SaaS solutions, and you do have a way to export as a CSV or maybe some reports. Again, dump everything in that bucket. Well, actually more buckets, but dump everything in a centralized place. So this is for data collection. Again, it's very simple, but it's so much better than nothing. You know, it's like Pareto optimal. It's 80% result from 20% effort. Now, for the data catalog part, so that your data scientist coming into the company will know where to look for data, just use a spreadsheet. Like you can add the name of a data set, who to ask questions about it, because this is actually like very important. Some description, maybe updates frequency. For example, I don't know, you do backup on daily basis, but you maybe scrap this stuff on a weekly basis. I don't know. And where is it located? Additional advice is not to override old data, but to append, basically. Storage is fairly cheap now, so I think most of the companies can afford it. Why? I'll explain a bit later. Next, so I mentioned that you need to seed that classifier, that model. Basically, all machine learning code at some point uses randomness. Now, randomness in computers, like a short ligbez, randomness in computers is not quite random. They use a random source of entropy, like the seed, but then the following numbers are generated based on some specific algorithm. So what does this mean? If you provide manually the initial value for the random number generator, you will always get the same sequence of random numbers, meaning that they are pseudo-random. And that's what you should do first and foremost when you do machine learning experiments. So all this seed, manual seed, all this stuff relates to this. Now, those of you who use PyTorch, most probably also will use graphics cards, right? So from NVIDIA. NVIDIA has this package called cuDNN, which is very cool and very low level, and it also does some internal fine-tuning. Now this fine-tuning can also be non-deterministic. You need to solve this. And finally, again, because machine learning code is very compute intensive, you will most likely use multiple cores and parallelism. Now, for this, you also need to seed your random number generators in each process, in each parallel thing that's running. And yeah, this is like 17, 18, and 19. It's just an implementation detail from PyTorch, because I use it more. Now, okay, so you made sure that your setup is deterministic now, as best as it can. But you also need to log configs, meaning like the parameters for your machine learning models. And you also need to log metrics, because now so for example, you'll say, oh, I got a very good model. Okay, what was the metric? Oh, I don't quite recall. It was something like 90 plus. So you don't want this. Log the metrics too. Now for experiment tracking, I personally use MLflow, because I also like to manage my infrastructure. A bit of a masochist, you might say. But if you have the money and your corporate culture allows to use some SaaS solutions, some good ones are Weights and Biases and Neptune AI. So they will be managing this whole thing for you. You just use the SDK, log parameters for parameters of the model, metric, well, I think it's clear already. You can also log some random stuff and log models. It's actually pretty cool because with this, you also have a model registry. So like you have container registries, now you can have model registries. Finally, for best results, you also need to track and version your data. And that's why I mentioned with the data collection that you shouldn't modify the data that you're putting in the bucket, but just append another file. That is because in time, you will be running experiments on older data when it is available in that bucket, in your data collection infrastructure. And because of that, like models trained on different data will give different results. So for full replicability, you would like to also like track multiple versions of your data set. All right. Yeah, so now you trained the machine learning model. What do you do next? You need to put it on a server to serve it, like you serve applications or like you serve APIs. So again, the simplest solution is to use Docker and some application server. It could be Flask, or it could be Gunicorn, and then again a Flask, or whatever. Now, if you care about SLAs, you should consider a more specialized solution. I prefer Reserve, but it's not for everyone, so maybe there is also Bento ML, like bento boxes. Now, if you care a lot about SLAs, then there is Triton Inference Server from NVIDIA. It's a beast. I had some nightmares with it, but it's very fast and it's very efficient. All right, what about tests? Like, ML code is still code, and you need to test your code, regretfully. Now, ML testing is a big and hairy problem because you don't only want to test code, but you want to test the behavior of a final model. How should you do it? Well, basically, you need a behavior test, or actually a suite of behavior tests, which measure predictions, and that can be also a regression suite. Because in time, you will notice that, for example, I don't know, you have a computer vision model and it classified a person of color as not a person. It's bad. It happened to Google. Now, to fix that, you, for example, will keep some examples of input images with people of color and make sure that the predictions for these images are always correct. And you just accrue this behavioral suite. And also you need unit tests. Now for the actual code, some simple examples is to make sure that, for example, while training your model, the loss decreases or the accuracy increases, whatever. Now, if you did everything up until now, CI/CD will come almost naturally. You have tests, you have packaging and deployment environment, packaging being Docker, for example, or those ML models. You can train models, you can train them reliably and in a deterministic way. Kudos for also triggering conditional steps of training the model if training code changes. Now you can do this with some Git magic, but we're not going to dive into it. Eventually you will arrive at the idea, well, why not use CI/CD? Actually, in our projects, we first did CI/CD for machine learning, and then we thought, well, we already have CI/CD, let's do this for code too. We went backwards. So, yeah, following advice is not going to scale, but that's all right. This is more like proof of concept ready, and it's much better than nothing, of course, and it's cost effective as hell. It's actually more cost-effective than using a paid solution or using an open source solution, but which is like full-fledged, you know? Now, why is that? Because at this point, when you start a machine learning initiative, there are a lot of unknowns, and you don't even know what you will need. So better start simple, understand better your context, and then decide and make a more educated decision on what tools you need and how will you stitch them together. Yeah, so these recipes are maximum return on investment with minimal effort. Most of this stuff can be done in a day, maybe two. Yeah, and as I already said, when you'll know more about your problem, you'll pick better tools. But start simple. Thank you.
Thank you. Thank you.
Amazingly, we have time for questions.
Yeah, we have a time for one question. Question, if we have it. Please, guys, don't be shy. They're too shy. It's the end of the conference, but they're still shy. Ah, there is a person who is never shy. Okay. The one who had to be our first speaker, but now he's our #1 for asking questions.
Yeah.
Привет.
He's going down.
Если это все так классно, почему оно не включено по дефолту?
Потому что, смотри, это как JS-фреймворки. Их много. Кто-то любит Vue, кто-то любит React, кто-то пишет на jQuery. Sorry. Типа на вкус и цвет. И плюс сейчас происходит так называемый Cambrian Explosion. То есть много таких, а мне вот тут не нравится, я сделаю по-другому. До хрена тулов, и приходится выбирать. Ну, типа, by default есть там у Google, у AWS, но, опять же, если взять все в пакете, то приходится там что-то допиливать. Потому что детерминистик будет намного, ну не намного, но там 15-20% медленнее. Ну, да, но во время экспериментов хочется, чтобы понять, что вот этот верняк, а потом уже будем оптимизировать на скорость. Вот это те 97%, которые можно игнорить.
Okay, guys, yeah, you can finish your discussion today at after party.
Thank
you very much, Alex. Thanks.